Okay, so walk me through this.
Okay, here we have a fore and aft marine compound steam engine of 2 horsepower. This is at 500 RPM, it will produce 2 horsepower. We're going to use compressed air here to demonstrate the engine. Normally, of course, it will be steam at about 150 psi to give us our 2 horsepower. Steam enters into the front cylinder system here. This cylinder is an 1.5" diameter piston with a 2.5" stroke. The steam does its work, both pressing the piston up and down, so it's double acting. The steam would then normally come out of this receiver line here, go into the rear cylinder where the temperature and pressure have been reduced. Does the same thing with a 3" diameter piston, so greater surface area required to get the power out of it with less pressure. And then after that, the steam would exhaust out the exhaust port, goes into a keel condenser system where it takes the steam back to water again, and then the water is drawn up via this pump, which I have apart right now, and then it's cycled into a tank where I filter it, and then the pump then takes that water and forces it back into the boiler for a closed circuit, so I reutilize my water over and over again, so minimal replacement water is required other than blowing the whistle and the leaks. So I'll start the engine running. This lever here is for going fore and aft. That's ahead and stern, and we'll just use some compressed air, and away we go. It's a little bit lopey on air. Steam has expansive properties, and so it'll run smoother when it's actually running on steam.
How long do you say it took for you to make?
Well, 20 years from the time it started to get the boat in the water. I'd worked at it at 8 hours a day. It probably would have been like 1 year maybe. I'll speed the engine up to about what the engine runs at when it's powering the boat at full power. So that's what it looks like when we be chugging down the lake at 5 miles per hour.
What's your RPM on it?
I'm going to throttle it down, make it more fun watching it run slowly than it is at full power.
What's the RPM at full power?
500 RPM is what it's rated for the 2 horsepower.
About how much torque would that be?
Have to work that out. Of course, horsepower is torque times RPM. I haven't spent much attention to that. I should have that memorized probably by now. Well, I'll demonstrate next. The engine, the way it's running right now, is for the boat going forward. And from the backside, the flywheel is turning in a clockwise direction. I'm now going to go into reverse, or stern. So I'll just reverse it. And there, whoops, normally it goes on its own here. That's it running in reverse. And normally, I'm going to give some more air here. That's running in reverse, that's running forward, that's running, reverse, and it doesn't stop there. So it's very easy to go from forward to reverse just immediately, so, you know.
Well, I imagine when it's got more pressure in it.
Oh yeah, the steam, once again, the steam's expansive quality makes it run smoother. This loping is kind of a problem for it, yeah.
Well, just the compressibility of air would act like suspension almost.
Yeah.
So what all is it made of?
I'll put the engine to a stop here so you can hear better. So in the traditional marine steam engine of 100 years ago, pretty well all of this would be cast iron and bronze. This one's got aluminum bed plate, aluminum frames. The cylinder covers are aluminum. And then there's cast iron parts inside there, stainless steel nuts and bolts that I put on there so it wouldn't rust. Bronze pieces, the connecting rods are big bronze chunks here. The main crankshaft is all just mild steel, and bronze bushings. So yeah, just a lot of this. Essentially, the kit, as if it were, was rough castings and blueprints. That's all I had. No instructions. You just had to figure it out yourself. And the fellow that designed this in the early '60s, Cliff Blackstaff, essentially made this so a person with modest machining abilities could build this in their home shop, as I did. And so the parts that they cast up were the parts you couldn't easily source from a junkyard. So all these shafts, rods, nuts and bolts, and bits and pieces you can get from anywhere. So you just go from your junkyard or to even Home Depot and source that. But all the main parts that required casting, they made those for us. And then I just have to take the lathe and milling machine and spin the parts on there to get them to be the appropriate shape and size and fit together. So it's a lot of work making this. For instance, on this pump here, having to bore out the center hole of the pump here to 1 inch in diameter, having to drill out where these caps are, where the check valves are, putting all the fittings in, silver soldering in sections there. So there were like several days of playing on the lathe and milling machine to get this component built up. Here's the part of the pump system. So once again, stainless steel rod. This was a piece of brass. And so all this, other than this cap here, was parts that I sourced. And this was a rough cast piece of bronze, and so I had to hex it with my milling machine, and I had to thread it with the lathe. So the rest is just bits and pieces, and where that spring came from I can't even remember. So all that kind of stuff. So
well, that's awesome.
Yep, yeah, lots of work. And fortunately I didn't screw up too many times machining the parts.
Well, thank you very much, sir.
Yeah, right.
Very informative.
Right, yeah.